So this is my talk about building universal TypeScript libraries, and I'm going to talk about some patterns that I've been learning over the years to build TypeScript libraries that are meant to run across multiple environments. So there could be browsers, Node.js, React Native, other places. So I want to see show of hands. Do you consider yourself an app developer? Okay. What about a library developer? Doing that? Yeah. So there's a few hands here. I think one thing to consider, even if you don't consider yourself a library developer, maybe you are, maybe there might be some parts of your application that you can take aside and build a library about. And also, you can be conscious about the things that I'm talking about here when you're evaluating libraries. Some of the libraries might use some of these patterns. Okay. You can also take some of these patterns and use them when you have a monorepository. So that's another thing to consider. So first a bit about myself. I built developer tools at MongoDB, primarily working on something called Compass, which is a GUI for querying, administrating database clusters. And I also help and maintain an SDK for something called the Atlas Device SDK. It's for TypeScript. It's a database meant for various runtimes, and that's where I learned a lot of this. It's a lot of TypeScript code and some C++ code, and it supports a very wide range of runtime environments, operating systems, and JavaScript engines. Outside of work, I'm also the proud father of 2 6-year-old girls and a 2-year-old toddler. And when I'm not working in my normal day job at MongoDB, I tend to build in public, and I work only 30 hours a week on my main contract with MongoDB. You can write to me on Blue Sky here, and any feedback for this talk or whatever is very appreciated. Cool. Enough about me. I want to talk about these universal TypeScript libraries. But what is a universal library or a package? It enables this idea about writing an application once and run it a lot of different places. And these packages are sometimes called isomorphic packages. There are examples here, the isomorphic fetch or the isomorphic WebSocket implementations. They can basically help you build either reusable apps, so you can do your implementation once and run it many places, on web, Electron, React Native, server-side, serverless functions. But you can also use it to implement some business logic against this universal library, and then run your tests, for example, on Node.js, even if you're targeting some other runtime environment, which is also a neat feature. Okay, so a trivial universal package is a package that doesn't depend on any runtime API, so it's just JavaScript. It doesn't have any special dependency on any runtime environment, and if you just have this, then you're good. But rarely libraries are that simple. Instead, they depend on runtime environments, and they're sometimes called platforms or simply just the runtime or the environment. It entails a JavaScript engine, so normally a runtime environment comes with a JavaScript engine, but you can also sometimes have situations where one environment supports many engines and the other way around. Yeah. So these are examples of different runtime-specific APIs. Could be globals when you're in a browser. Could be navigator, fetch. Fetch now comes on Node.js. Console log is actually not a part of the language, so it's something that's a de facto standard, but still considered runtime-specific. The process global from Node. Bun has different globals that you can use to interface with the file system. Stuff like this, Deno the same. And sometimes there are packages that are, or built-ins, that could be the file system from Node or some React Native specific to get some idea about the platform you're running on. All of these are different examples of runtime-specific APIs. And the golden rule, or the thing that you want to do when you write a universal library is to separate the runtime agnostic, like the common code, from the code that is runtime specific. And this is like the naive approach. Is like you have your package, you have a main field, it points on this common entry point, and then inside of it, it would conditionally import some browser-specific code or some node-specific code in this example. How would you go about like doing something like this? You might want to turn to runtime checks, for example. So that would be like, if the browser global or the window global is there, we're probably in a browser. We hope so. Otherwise, if the release name, the process release name is Node, then we're probably in Node. Can somebody tell me what might go wrong or why this wouldn't be good?
You have many different browsers and windows, so it's making it really hard to understand which browser you have.
Yeah, so you don't know exactly what kind of browser you have? Yeah? Yeah? Yeah, the window there could be undefined. The process, yeah, exactly. So in this case, for example, if you run this in Node.js, it would try to reference a global that's not defined, and that would be a runtime error on Node. That would be an issue. But also, we could check for that, right? We could do like a type of, the type of operator allows you to put in something that might be undefined, which is better, I guess, arguably better, but here you can see you need to do the type of process is not undefined and the process release is not undefined, and then you can actually access the thing, right? And why might this go wrong? Does anybody know?
If neither fits, what's the else?
If neither fits, yeah, what might be, that's true. There might be some like condition that's not met, yeah? Maybe, yeah, maybe somebody, something might be setting browser in a test, yeah. That's the thing, right? Maybe some dependency or your test or whatever is mocking the browser global, or like the window global, and then you think that you're in the browser, but you're not. It's also very, very hard to test because essentially these will fail in the circumstances that you didn't anticipate, right? You didn't anticipate this other third thing that you talked about, this like, what about the branch, the last branch? So that's some of the issues that are with these runtime checks. Even if you manage to define, let's say that you did manage to define this constant is Node to figure out if you're running in a Node process, then you might want to be tempted to do like a require for the file system package. Can anybody tell me what might go wrong here? Sorry? Yeah, you might not have access to the file. Yeah, maybe. In this case, the problem could be that your bundler tries to eagerly like resolve this file system built-in, but if you're bundling for a browser, you don't have it. So these require calls, they mess up bundlers. That's the specific thing I was thinking about here. And you can do something ugly to try to try to work around this, like, nah, trust me, it's a specific require function, or like, I'll just rename it here. It's like an endless rabbit hole of different ways of working around this issue. And I want to turn your attention to something else, a different approach, which is conditional exports. It's actually not super new. I think it's around at least 5 years old. But it's not catching on as much, so that's also why I want to talk about it. Instead of having this common thing that does runtime checks and then imports specific or runtime specific files, you can turn it around and you can declare the different entry points. In this case, if you're a browser, you load this file. If you're Node, you load this file instead. Show of hands, have you seen conditional exports or export conditions? That's a good crowd then. So in this case, I've turned it around and have these two entry points import the common code instead. And you can use these just by defining this in your package.json. You define an exports field. And then you can say my entry level of my mylib package, in this case, has types over here, Node implementation here, and a browser implementation here. Then when you have these, so these conditional exports, like the names that are used here, node and browser, they're defined in the Windows CG. It's like an RFC that you can see different runtime environments declaring how they or what they expect in this scenario. Okay, so I'm going to go into some of these. So for TypeScript, for example, if you have special types for your browser, when you're writing an app consuming a library that declares that it has specific browser types, for example, you can use these custom conditions in your compiler options to say, actually, I want to have the browser types for this package. It's often not needed because what we're talking about here is like a universal library that exposes the same API across different runtimes, right? So normally it's actually not needed to have like these specific browsers, but you can do it if you want to. You can also use it to declare experimental APIs. Like let's say that you have an export conditions that's like experimental, and you can ask your users to define this, and then they would have the experimental API available. Okay. In Node.js, you can declare these conditions, and that will inform the resolver of Node as it's resolving files to be looking for specific conditions as it's importing files from packages. In a bundler read roll down here, you can define conditions, a list of conditions. Normally, some of this would be in a preset that you use when you have a preset for browsers or a preset for Node. Then you would this would be filled out for you. But this is RSPack, for example, and Metro. Because I'm doing a lot of React Native, this is enabled very recently by default now, which is awesome. So we see like this many more bundlers and runtime supporting this. The next thing I want to talk about is something called subpath exports. Have anybody seen this? Show of hands. Okay, yeah, a little more. So it's basically a way, almost the same as the export conditions, but now we're talking about specific subpaths of our package. It used to be the case that you could just like import from anywhere inside the package, right? But now we're given a way to declare, for example, here, if you're importing the /common part of my package, you'll get this file. And then I still have these two browser conditions available. So I can basically point to the common stuff, or I can point to just the entry point. So it's the same here in the exports. Instead of the dot for the root, we do dot/common. And you can nest these. Like instead of providing a string, you could actually also provide an object with export conditions. So you can like mix and match. Okay, next up I want to talk about these TypeScript project references. Have you used this, any of you? You have? Yeah? Okay. This is a very neat way of structuring your TypeScript programs into smaller pieces that can be independently built. It's actually about 7 years old, so it's been around, but I don't see that many people using them still, even though they're very powerful. In this case, this project that I'm working on is defining different TS configs for each of the runtime-specific parts of my project and one for the common code. And I have this one root TS config that says I'm declaring no files. Like the root of my project has no work to be compiled, or no files to be compiled, but it has references to 3 other things. One is the TS config for the browser stuff. I say everything that's inside my source browser is browser specific, and it produces this dist/browser artifacts, which I point to from the browser condition in my package.json. The same for the node, just a different directory, and then I have some tests that I point to with a specific file glob here. And I say that all of these 3 over there, they all depend on the common code, which is everything in source common, but excluding the tests. Yeah. Any questions for this slide? Okay, makes sense. So when I look at these different TS configs, Again, I'm declaring no files, and I have the references for the other three main or like sub-projects of my TypeScript project. I already went over that. This is for the common. I'm basically saying I include only the common source code. I exclude the tests because I don't want to have that a part of my common code being emitted. I extend this recommended TypeScript config, and I have to declare that this is composite, and this is the way I opt into these. This makes the common TS config here being eligible for being referenced by the root. Okay, next up I use this module, and module resolution is just a way of deferring if I'm gonna be using CommonJS or ECMAScript modules. When I have this configuration, it defers to the package.json type, so that's a way of making that less repeated. I say that I'm gonna output into the disk common, and the root directory of my code should be source common, the same thing that I include down there. It's just a way of making sure that the files end up in the correct place. The common code is only allowed to reference ECMAScript APIs in this case. So I say, like, you can reference ECMAScript in this version, 2022, and I declare that you're not allowed to use any other types. You can't. If I had like a third-party dependency, I could put it here. But right now I'm just saying, like, don't do any resolving of your own. And I also make it more explicit. If I include some type file, that file is not able to resolve itself, its dependencies. So it's even more locked down. This ensures that my common code won't suddenly get some node global being available. Like, I want to make sure that I only have the APIs available that will actually be there commonly across all the runtimes I support. Okay, for the test here, I extend the common code, so it's like a specialization of that. Now I include only the test files, and I reference the common code. So it's like basically referencing backwards, right? But here I allow, here I say that I only want to have declarations emitted, so I don't want to have JavaScript emitted, because I want to run these tests ephemerically. Like, I don't want to have files on my disk when building this project, for the tests specifically. And I say now you're actually allowed to use the node types, because I want to use the node test runner to execute things. So when I'm defining my test, it's okay to use node, but the common code is not okay to use node. And because node here does use something that needs this resolve to be false, I need to set it to false. For the browser stuff, I include only the thing in source browser. I reference the common code. I extend the recommended settings here, and then again composite. This is the same. Now I output to a different directory, and I allow both ECMAScript features, but also the DOM API. So now all the things in source browser is able to access, document, window, all that stuff. And again, declaring no types. Like, I have no types that I want to additionally depend on. And for node, it's almost the same thing. The only difference here is, of course, I set the output directory to something else. And I don't have the DOM API anymore, but I do allow the types for node. So that means I can do import from FS, for example. Okay. When you build these project references, you can do TSC --build, and that basically consumes your project. It will figure out the dependencies between the projects and build them in the right order. You can also do a clean build that will basically just delete all the output files. Sorry, this will just delete the files. This will do a build, first a clean and then a build, if you use the force. You can do verbose to get more insights into what projects are actually being accessed or referenced. And you can do a watch as well. And one nice thing about this is also, when you opt into the composite option, you get incremental builds by default, which makes the TypeScript compiler much more faster, because it can basically catch up between invocations of the compiler, so it won't do duplicate work if you didn't change files. You can still point the TypeScript compiler to specific projects, in this case the tests, if you just want to run the compiler for just those tests. But the only caveat here is like you need to make sure that this include and the out directory is correctly configured. The warnings here is not like they're not good. If you have two projects emitting files to the same path, it will just say something like this was built wasn't built by this project or something. Like it's a very obscure error, and it's not easy to figure out like what actually emitted those files. So that's something to keep in mind. Okay, so one common question when you author a library is like, should you use CommonJS or ECMAScript modules? And I think I tend to lean towards like a newer standard. ECMAScript modules is more expressive. It has this discrepancy or the difference between dynamic import or versus static imports, where CommonJS only has this dynamic require API. It enables static analysis of the dependency tree to visualize, which is neat for tools. And tools supporting JSC, they need to use these heuristics in the case of the bundler that we saw before, where you would figure out there's a require call. It's probably trying to take that file into the bundle, but it's not super rigid, I guess. And tree shaking is still possible when you do CommonJS, but I think ESM sometimes have a stronger. It might be easier for bundlers to figure out what it can shake when you have ECMAScript modules with static imports. And I think ECMAScript modules is still the future. Yeah. Another thing to take into considerations, there is something about when you use ECMAScript modules, you need to, when you have a TypeScript file and you do an import of a sibling file, you need to do whatever, child.js, even if you're in a TypeScript file, which is mind-boggling to some people, and you can avoid that if you use CommonJS. Some people feel very strongly about that, to the point where they would actually go for CommonJS instead. There's these polyfills for basically importing CommonJS files. That's much more easy to implement than the other way around, where you try to require an ECMAScript module, because the semantics are basically different, like they're extended in the ECMAScript modules. Node.js recently added support for this without a feature flag in this version. I also saw that it got backported to version 22. And that's great, but it also, you need to avoid these top-level awaits. That's a feature of ECMAScript modules. If you want to be able to be required as an ECMAScript module, you need to avoid those. And you could do both if you really need to. But I would say, like, try not to do it first, and then if you get issues or people complaining, maybe you can tell them how to do it themselves, or I don't know. And then be aware, if you do both, you will have duplicate code, and potentially somebody consuming your library might be able to load like two versions of your library at the same time, the CommonJS and the ECMAScript, which might cause problems. You can also use these conditional exports, like the require and import conditions. Tell if you want to load me as a CommonJS, this is the file. If you want to load me as ECMAScript module, this is the file. So that's something you can also lean into. Something a little more maybe controversial is publishing bundles. Some people do this, where they basically take all the library code and bundle it into a single file. I think it rarely makes any sense, to me at least. It makes it harder to, or impossible to selectively import the different files. The thing we saw with the subpath, like you cannot point to the file underneath if it's all in one bundle. I've never seen this work with this thing called declaration maps, where you can basically jump to the implementation of the code in your, when you get like some error and you look at the stack trace, you can sometimes, if you use declaration maps, you can actually jump into the file, the TypeScript file that was actually implementing this. That's the source map part, but then also when you're in your editor, you can click a function definition and jump into the source code implementation. And I've never seen that work with bundles. One thing that I have used bundle for is I've bundled Mocha, for example. It's like a test runner that I used a bundler to basically make a platform agnostic, like a universal version of that. I think bundling is good for something like that. Anyways, and remember that users might likely be bundling themselves. So that's also something to consider. Okay. You can ship TypeScript source code as well if you wanna. I don't think you should do it for allowing people to build from source, because they would need, first up, like TypeScript code is coupled to the configuration and the compiler version, so that's rarely a nice thing. Maybe if you use a composite project that I showed earlier, you might give people a possibility of consuming your TypeScript code from source. Also, if you have other dependencies, dev dependencies, they will not be installed. So I think it does enable this go-to definition that I talked about. And these declaration maps are good for it, especially in a monorepo. But I think that's... I can see that I'm running out of time here. Yeah, I want to go very quickly over some of the patterns. I have 3 patterns left, okay? So this is, I know I'm between you and lunch, so I'm conscious about that. So the runtime specific injection, that's a pattern where I have this common code. In this case, it's a greeter, it's greeting from somewhere. In my browser implementation, I patch that static, and then I re-export my common code, okay? And in Node, I do the same, but I greet from somewhere else. Here you can see I'm using process versions Node or the navigator user agent. So I have this runtime specific APIs available. Yeah, the next pattern here is stripping internals. That's when you have some secret internal function. You can annotate it as internal, and you can, this is the TypeScript declaration normally. This would be emitted, but if you ask it to strip internal, this is what you get down there. It will basically strip the declaration out of the file. And the documentation says you should use it at your own risk, because it doesn't do type checking. So you need a separate type check step here in this case. Like I run the compiler again, saying I don't want to have it emitting anything, but I want to have it check my public types that might have some internals stripped that might have broken. And the last one, I call it module augmentation through a subpath export. This is if I have some experimental API. I can see here that my greeter is also able to yell in this case, and I bring the implementation here, and I can declare that I have this experimental yell that you can import. And if you do that, in this case first, it will say, if I don't import the experimental yell, it will say property yell does not exist. But if I do it, it would augment my browser package declarations to actually say, well, actually now it's available, and then you can call the function. So that's a way of, like a pattern of building experimental APIs that you can have your users test out. Okay, very last things. Is, if you want to figure out what file is resolved, I built this thing called Resolution Explorer, which basically invokes the TypeScript compiler and figures out why was a certain file imported into my project. So you can navigate here and you can go into a specific type, search, filter, like you can see this is why it was found here, or yeah. And then the next one is if you, I did a talk about testing these universal libraries that you can also, it's on gitnation.com. Cool. This is what I already said. Do you use conditional exports, subpath exports, and project references? ECMAScript modules are cool. Source maps are great. Declaration maps, especially in a monorepo. Please give me some feedback on the QR code here.